bits. So if input is this one, we're counting all those bits with 1, so the output should be 3. In this case it's 1. So the way we're going to solve this problem, so it's a binary string of length 32, and the way we're going to solve it with bit manipulation. So specifically with AND. So when AND, if 1 and 0, then this becomes 0, and when 1 and 1, and this becomes 1. So from here we can actually see that 1 is turning into 0 from here. So what we can do is that, let's say there is a number n which has 0, 1, 0, 0, and then corresponding in negative 1 has, let's say I'm just like saying, just coming up with numbers, so it will become 1, 1. So when we are making AND, the output of this one becomes 0, and 1 and 0 becomes 0, the rest becomes just 0. So from here you can see there was only 1, so 1 is turning into 0. So let's come up with other. Let's say if it was this one, so in this case it would have been staying 1, and then we can again for this given number get this negative 1 of it, and then that will become also basically 0, 0. So in each iteration we can count the numbers. So in code, let's see what we are going to do. We'll have our count, which will count all those zeros, all those bits, and then while given n is not equals to 0, because eventually it will become 0 like in our iteration. So until this doesn't become 0, then take this n and then go do the end of it just like this. So every time this will be dropping 1 by 1, and in there we can count our number. So return count. Perfect. So time complexity in this case is, in worst case, you can take 32 bits, and that's what it was saying in the description. The input of the 32, so it's a constant. We can say O of 1, and space, we're not using extra space, so it's O of 1.